Inside Silicon, the technology behind everything. Powered by Semionix.
Let's talk about something that's happening just beneath the surface of the AI gold rush. We're all focused on the models, the software, the incredible things AI can do. But the real question, the one that might define the next decade, is this. Is our hunger for AI actually creating a global chip crisis? I mean, think about it. Right now, every single major company, every government, they're all in this mad dash for AI supremacy. They're spending billions building massive data centers, all to get a computational edge. It is a sprint on a global scale like we've never seen before. But what if the biggest problem isn't the code? We hear all about the large language models, the algorithms, but the real bottleneck, the thing that's slowing everyone down, isn't software at all. It's something much more physical. Yep, it all comes down to the hardware, the specialized silicon chips that are the engines for this entire revolution. And the demand for these chips is creating a kind of pressure that the semiconductor industry has, frankly, never had to deal with before. So let's start with the sheer scale of this demand, because you really have to understand this to get the problem. We're not just talking about a little more demand, we're talking about a totally different kind of consumption, a whole new level of computational appetite. You see, training a big AI model isn't like just running an app. It's an act of brute force computation. You need thousands of high-end GPUs, all networked together. Each one of those GPUs needs to be fed data at incredible speeds, which requires huge stacks of something called high bandwidth memory, or HBM. And then all of that needs to be stitched together with incredibly sophisticated advanced packaging techniques inside a massive data center. It's a whole ecosystem. And here is the really critical part. All of this world-changing demand is funneling down to the most advanced, most difficult to make chips. We're talking 5 nanometer, 4 nanometer, and now 3 nanometer nodes. And the vast, vast majority of the world's capacity to build these chips, it's at one company, TSMC. This creates a massive, systemic choke point for the entire planet. Okay, now let's get down to the silicon level, because this is where it gets really interesting. To see why AI is putting so much strain on the system, you have to realize that not all chips are built the same. AI chips, well, they're basically monsters. Just look at the difference. A chip for your smartphone is designed to be small, efficient, to sip power. An AI GPU, on the other hand, is a beast. It has a massive physical footprint on the silicon, what we call a die size. It's packed with way more transistors, and it's incredibly power-hungry. They are just in a completely different league. And that physical size has enormous consequences. You see, we make chips on these big, round silicon disks called wafers. With those small smartphone chips, you can cram hundreds, maybe even thousands onto one wafer. But these giant AI GPUs, you're lucky to get a few dozen. So every single AI chip that gets made eats up a huge, disproportionate slice of our most valuable resource, our advanced wafer manufacturing capacity. All right, so just getting these things fabricated on a wafer is a huge challenge. But believe it or not, that's just step one. The real squeeze, the bottleneck that's causing insane delays right now, actually happens after the chip is made. A modern AI chip has to run a gauntlet to be born. It gets fabricated, sure, but then it has to go to this incredibly complex and delicate process called advanced packaging, where it gets integrated with all that high bandwidth memory. Every single one of these steps is a potential point of failure. So what exactly is advanced packaging? The best way to think about it is like microscopic three-dimensional surgery. You're taking the main GPU chip, multiple stacks of HBM memory chips, and you're carefully stitching them all together into a single super powerful processor. It's an absolute marvel of engineering, and it is totally non-negotiable for getting the performance that AI needs. And the result of all this? Well, the demand for these advanced packaging services has just gone through the roof, and the suppliers can't keep up. So lead times that used to be a few weeks are now stretching into months and months. You can have perfectly good silicon wafers just sitting there, waiting in line to get packaged. Now, when one customer starts sucking up all the oxygen in the room, it creates a massive ripple effect. When AI is consuming so much of the world's most advanced chip capacity, what happens to everyone else? I mean, let's just think about the business here. Chip foundries have a limited amount of equipment and time. So if you've got the AI giants showing up, willing to pay huge premiums for every single wafer, for every single packaging slot, well, who do you think gets bumped to the back of the queue? And this is exactly what we're seeing. The auto industry, which relies on older, less profitable chips, is at risk of getting crowded out. Makers of mid-range consumer gadgets might find their orders are suddenly a lower priority. In other industrial sectors, they're starting to see real supply instability. It's a battle for a spot in the production line. Oh, and there's another crisis happening at the exact same time: memory. An AI chip is basically a paperweight without its high bandwidth memory. An HBM is just ridiculously hard to make. It involves stacking memory dies with micron-level precision. And just like everything else, the supply is totally struggling to keep up with the GPU demand. So, when you put all of these pieces together, you have to ask yourself, are we using the right word here? Is shortage really what's happening, or is it something different? Think about it. A classic shortage is when some unexpected disaster happens and suddenly there aren't enough chips for anybody. But this feels more like a strategic reallocation. The industry's finite, precious capacity is being consciously aimed at the customers with the deepest pockets and the biggest performance needs, the AI companies. And that, right there, is the heart of the issue. AI isn't just another customer in line. It is quickly becoming the single dominant force, the organizing principle that dictates how the entire advanced semiconductor industry allocates its resources. And a shift this big doesn't stay technical for long. It becomes geopolitical. This is why you're seeing massive government investments like the CHIPS Act. It's why there are strict export controls. It's a global race now, where nations see control over the chip supply chain as absolutely fundamental to their power and security. Which really boils it all down to a simple, powerful truth for our modern era. It's not just about traditional measures of strength anymore. In the age of AI, compute is power. And that leaves us with one final, and maybe the most important question of all. In a world where this incredible power, this computational capacity is finite, and it's being allocated, not just sold, who gets to decide? Who decides who gets this power and who has to go without? That's the question that's going to define our technological future. Thanks for joining me.
Inside Silicon, the technology behind everything. Powered by Semionix.